This is a problem that involves the probability of at least one. At Greendale College, the freshman dropout rate is 1%. If 3 freshmen are randomly selected, find the probability that at least one of them will drop out. So here are the key words, at least one. Okay, let's see what information we've been given. We've been given this dropout rate. So the probability that a freshman would drop out, and to make my writing a little more efficient, I'm going to change this to the probability of a capital D to represent drop out, is 1%, or written as a decimal, 0.01. Now, in previous problems of at least one, we weren't given a rate, a percentage. We were given, for example, in the e-reader problem, we were told that 7 out of 10,000 of the e-readers were known to be defective, and we computed this, 7 over 10,000. In this example, we have not been given the number of college freshmen at Greendale College, and then therefore the number that had dropped out. For example, if they said 5 out of 500 freshmen drop out, then we would have to compute this 1%. But since they went ahead and gave us the rate, we didn't have to do that calculation. Okay, so a freshman at Greendale College or any college either drops out or they don't, they stay. So those are complements of each other. So we need to consider the probability. What's the probability that a freshman would stay? And so I'm just going to call that the probability of S. Well, since these are complements and this is all of our sample space with regard to whether a freshman stays or drops out, those are the two choices. So this would be the probability that a freshman would stay would be 1 minus the probability that a freshman would drop out. So that would be 1 minus 0.01 or 0.99. So the probability that any randomly selected freshman will be on campus the next year is 0.99. Well, we're interested in finding out the probability out of 3 freshmen that have been selected. What's the probability that at least one of them will drop out? Well, let's think about our sample space for this. So we've got the 3 students, and we find out, we've selected them, and then we find out the next fall who's there and who's not. And out of those 3, we could find that they're all still there. We're looking for dropouts. They're all still there. We had 0 dropouts. Or 2 of them come back, so 1 of them dropped out. Or 1 of them comes back, so 2 of them dropped out. Or they're all 3 there. So the probability of at least 1 dropout, 0 dropouts, 1 dropout, 2 dropouts. I said all 3 there, but all 3 drop out. Sorry, that was an error. So 3 represents all 3 students drop out. None of them return the following fall. Okay, so the probability of at least 1 dropout, well, we said we can calculate that by finding the probability of everything 1 and higher, because at least 1 means 1 or anything greater than 1. So that's the probability that we have 1 dropout or 2 dropout, who drop out, or 3. Right? And then we said that was the probability of 1 plus the probability of 2 plus the probability of 3. Because these are disjoint events, there's no overlap, we don't have to worry about subtracting off any double counts. But I wanted to show you the thought process there, but then now you're probably thinking, but we saw a better way to calculate this, and we did. The probability of at least 1 dropout? Well, we could use complements. If we're interested in 1 or 2 or 3, well, there's only 0 left, so we could say, well, that's the entire sample space 1 minus the probability of 0. Okay, so what would have to happen to have the probability of 0, or to have 0 students drop out? Well, that would mean that we would have the probability that, and I used an S for stay, that the first student in our random sample stayed, and the second student in our random sample stayed, and the third student in our random sample stayed. Okay, well, what's the probability that, well, let's write this then. For independent events, that would be the probability of S1 plus, multiplied by probability of S2 times the probability of S3. Well, what's the probability that any one student would stay? That's 0.99. So that's 1 minus 0.99 to the third power, because these would all be 0.99, which is equal to 1 minus 0.970299, or 0.029701. And let's just round that then to 2 decimal places, 0.03. So what we have found, our interpretation, is there is a 0.03 probability that at least one of 3 randomly selected freshmen will drop out. And lastly, let's answer the question of whether or not this would be unusual. Would it be unusual if you randomly select 3 freshmen on campus and that at least one of those 3 does not return in the fall? What would you say? Well, we would say yes. And why? Because 0.03 is less than or equal to 0.05. It's less than, right? And that's our unusual cutoff. Anything 5%, 0.05 or less, any probability that's 5% or less is considered unusual. So we would find it unusual if we randomly select 3 freshmen and then find in the fall that at least one of them dropped out of those 3. Now, I want to go back to one thing that I kind of skipped over quickly. I said here that we were calculating for independent events. However, of course, selecting these 3 students would be dependent. It would be without replacement. You wouldn't want to possibly select the same student twice. So why did I just go ahead and assume independent events? I didn't do any calculations for meeting the criteria. But recall, we weren't given the number of freshmen. We know our sample size, N, is 3, but our population, I don't know. And remember, the calculation says, well, if N is less than or equal to 5% of N, large N, the population size, then you can treat dependent events as independent events. But I didn't know the population size. And what I failed to mention was that in this case, I'm just going to make the assumption that this population would be 60 or larger, at least, at a college of freshmen. If it were 60, then 3 is less than or equal to 0.05 times 60. So I'm going to put say N equals 60. Then we're right on the money because 0.05 times 60 is 3. Okay? So I made the assumption that N was 60 or greater than that. Anything larger than that would make this hold also. So I made that assumption, and and when I got to this calculation, I used that rule and calculated these as though they were independent, because I was able to in my mind, make that fit the criteria, but I needed to explain that.